This is a question about the dark fringe in the interference of bichromatic light. There's a YDSC setup which is made up of a bichromatic light. It consists of wavelengths 4000 angstroms and 3000 angstroms. The slit separation is given as 2 mm and the distance between the screen and the slits is given as 40 centimeters. We are supposed to calculate the distance of the first completely dark fringe from the central bright fringe. Now, in this type of question, we need to understand that the fringes which will be formed, they will be formed because of one wavelength of light and the other wavelength of light. So because of both these wavelengths, there will be different fringes which are formed, and if these fringes overlap each other, that intensity will be recorded. Now, if we want to find out what is the distance of the first completely dark fringe, so we need to understand the completely dark fringe will be formed at the position where the dark fringe due to this wavelength and the dark fringe due to this wavelength coincide. So let's start with the solution for this. First, we find out the distance of nth dark fringe due to lambda equal to, let's say, 4000 angstroms. Now the distance of the nth dark fringe, let's call it as xn dark, that should be equal to 2n plus 1 lambda d by 2 small d. So that will be the distance of the nth dark fringe due to wavelength 4000 angstroms. Now similarly, we can find out the distance of let's say mth dark fringe due to wavelength of 3000 angstroms. Now this nth dark fringe was equal to 2n plus 1 into d by 2 small d into 4000. Similarly, here the distance of the mth dark fringe will be equal to 2m plus 1 into lambda capital D by 2 small d, which will be equal to 2m plus 1 into d by small d into 3000. Now completely dark fringe is observed at a position where the dark fringes due to both lights coincide. Now completely dark fringe will be where this dark fringe and this dark fringe coincide. So we can say the distance from the central maxima will be x and d, that is the distance of the dark fringe of the first wavelength, that should be equal to the distance of the second wavelength, that is equal to x md, right, 3000. So from here we can say that 2n plus 1 upon 2m plus 1, this comes out to be 3 by 4. Now for different values of n and m being integers, for different values of n and m, we can see that this value 2n plus 1 will be an odd number, as well as 2m plus 1 will be an odd number. So the ratio should be an odd number by an odd number, but here from the given data we find that this is an odd number but this is an even number. So the ratio of an odd number with an odd number cannot be an odd number and an even number. That's why this situation is not possible. So for any values of n and m completely dark fringe will not be obtained. Thank you.